This is a 1P IGCSE Edexcel past paper from June 22. Sorry if you can hear that noise, it's my cat eating her dinner. The diagram shows a comet as it moves through part of its orbit around the Sun. Add an S to the diagram to show the position of the Sun. So the Sun will be over here. Remember that the comet travels fastest when it's closest to the Sun because it has the strongest gravitational force, and remember also that the comet has a highly elliptical orbit. Complete the diagram to show the orbit of the comet. So let's complete that ellipsis. Add an X to the diagram to show the position where the comet is moving fastest. So that is the closest position to the Sun. So around here. Describe how the orbit of a comet compares with the orbit of a planet. So 3 marks, but let's make 3 separate points. So I've already mentioned firstly, comets have highly elliptical orbits. Planets have a circular orbit. Because of that ellipsis, we know that, and we've already mentioned it, the comets travel at different speeds depending on how close they are to the Sun. And then the last thing we can say is that both orbit the Sun or star, doesn't have to be our Sun. Which statement describes the term atomic number for a nucleus? Gosh, we've just dipped into chemistry here. Remember, that's to do with the protons in the nucleus. So is it A, the number of electrons? No. Is it the number of neutrons? No. Is it the number of protons? Yes. Is it the number of protons and neutrons? No, because remember, that's the mass number. Which statement describes the mass number? Gosh, I keep answering these questions before I get to them. It will be this one. Which statement describes the term isotopes? Remember, it's atoms of the same element with the same number of protons, but a different number of neutrons. You will have to learn that definition so you don't get confused between the options. The answer is D. An atom contains 8 protons, 8 neutrons, 8 electrons. Which of these would result in a negatively charged ion of the same element? So remember what you're going to do in order to be negatively charged. You're going to either gain electrons or losing protons. But the key term here is it's the same element, which means we need to keep the same protons, because remember the proton number dictates the element, which means it's this option here we're going to have to go for. So the answer here is A. It's not possible to predict exactly when a radioactive nucleus will decay. Which feature of radioactive decay best explains its observation? Remember, it's because it's very random. So the answer here is B. Which of these is the correct unit for measuring the activity of a radioactive sample? It is the becquerel. Coulombs, remember, measure charge. Joules is energy. It's always good to make sure you know why other answers are wrong. This is power. An ultrasonic distance measuring device can be used to measure the length of a room. The device emits a pulse of sound with frequency of 40 kilohertz. The device also emits a bright beam of red visible light. Explain what is meant by the frequency of 40 kilohertz. So frequency means the number of waves per second, and then connect it with that 40 kilohertz is 40,000. A sound wave from the device travels at this. State the formula linking wave speed, frequency, and wavelength. It's up to you if you write it out in words or like this. Calculate the wavelength. Don't worry about rearranging. You can just substitute it in like this. So the wave speed is 345. We know the frequency. Get that into hertz. So it's 40,000 times the wavelength. To find the wavelength, divide both sides by 40,000 to get 8.6 times 10 to the minus 3 meters. The device emits a sound wave. The sound wave travels to the wall, reflects back, and is received. The distance from the device to the wall is 2.35 meters. I'm just drawing that. Calculate the time between the sound wave being emitted and received by the device. So this is the formula triangle. So time equals distance divided by speed. Remember that distance, it has to go to the wall and back again. So it's 2 lots of 2.35 meters. We know that the speed is 345. So our final answer, I think it's not very much working for 4 marks, but is this. I'm finding that a bit disconcerting personally. Let's go to 3 significant figures. Suggest why the device emits visible light so that the person can see what they are measuring. Sound waves and light waves can have different frequency and wavelengths. Describe 3 other differences between sound and light waves. You may draw diagrams to support your answer. So, sound waves are longitudinal. So remember, if we were to draw that, you have areas of rarefaction and compression. So where that's closer together, you'll have a compression. Here's your rarefaction. Whereas light waves are transverse. We could also say that light waves are transverse and they are electromagnetic waves. Remember, they belong to the EM spectrum, visible light, whereas sound waves are longitudinal and are not part of the EM spectrum. So remember, sound waves are not part of the electromagnetic spectrum. I've also added this point down here that light waves can travel through a vacuum, whereas sound waves cannot. So you get a mark for describing whether they're longitudinal or transverse, the diagram, whether they're part of the EM spectrum or not, and this point about travelling through a vacuum. The table gives data for some planets in the solar system. Plot a bar chart of the gravitational field strength for each planet. So make sure you're looking down the right column. It's this one. Just copy that table heading for your y-axis label. Just literally copy it out. Now let's get our axes sorted. There's your y-axis. There's your x-axis. Be sensible. We're going from 3.7 up to 23.1. You want to take up as much of that graph paper as possible. Yep, this is looking sensible. And then we need our planets along here. And then just plot it nice and accurately. So Mercury is 3.7. Venus is 8.9. Jupiter is 23.1. Saturn is 9. Uranus is 8.7. It's hard to draw it really accurately on my iPad. And Neptune is 12.7. Suggest why planets have different gravitational field strengths at their surface. Remember, that's linked with the mass of the planet because they have different masses. Give the relationship shown by the data in the table between the orbital radius and the orbital speed. So let's look at something like Jupiter. That's got the largest orbital radius. Remember, it's a massive planet. It has a slow-ish orbital speed. Let's compare it with something that's much smaller. So Mercury, it has a much faster orbital speed. So we'll make a statement that is the larger the orbital radius, the slower the orbital speed. Then I can see we're being asked about orbital speed. So I'm going to steal the equation. Make sure you do use this. It's this one here that I can see I need to use. I will read out the question to you. Calculate the time period of Mercury's orbit around the Sun. So what is the orbital speed of Mercury? Well, it's 47.4 kilometers per second. That needs to be in meters per second, which means we need to times it by 1,000. And then our orbital radius is 57.9 times 10 to the 6, but that's in kilometers, so we need that in meters. So we need to times that by 1,000, so that becomes times 10 to the 9. And then solve for t by doing 2 pi 57.9 times 10 to the 9 divided by 47,400 to get this number, which is 7.7 times 10 to the 1, 2, 3, 4, 5, 6. A material called granite is used as a work surface in a kitchen. Granite is formed naturally and contains radioactive isotopes. Granite worktops contribute to background radiation. Give another naturally occurring source of background radiation: cosmic rays, medicine, X-rays, food, etc. Granite contains the isotope thorium-232. Thorium-232 decays by sequence of alpha and beta decays to form radon. State two differences between alpha radiation and beta radiation. So remember, alpha is heavier, as it's 2 protons and 2 neutrons. Beta is negatively charged, whereas alpha is positive. Because remember, beta is effectively a fast-moving electron. The incomplete nuclear decay equation summarizes the decay sequence of thorium into radon. Calculate the number of alpha and beta particles. So whatever is on this side must add up to on this side. So we need to get from 220 to 232, bearing in mind that beta has no mass, and we know that alpha has a mass of 4. So to get from 220 to 232, we need to multiply that by 3, so we need 3 alpha. And then what about looking at our proton number? We need to get from 90 to 86, bearing in mind we've got 6 here. So if we were to take 6 away from 90, we'd get to 84, but we need to get to 86, so that's why we need 2 lots of this -1. So it's just literally doing like a puzzle, making sure the numbers add up. Thorium is a solid and remains in the work surface. Radon is a gas and is emitted. They both emit alpha radiation. Discuss the hazards due to the granite work surface when a person is working in the kitchen. Refer to contamination and irradiation in your answer. So let's first of all talk about the fact that they both emit alpha radiation. Alpha radiation is an ionizing radiation. Which causes cell mutation and may lead to cancer. Let's look at this point now about whether it remains in the work surface or is emitted. Because the radon is emitted, it means that it can cause both contamination and irradiation. Whereas thorium can only cause irradiation as it remains on the work surface. The diagram shows a child on a zip line. During the ride, the child slides along a metal wire with the velocity in the direction shown. The diagram also shows the tension force acting on the safety harness. Force and velocity are examples of vector quantities. What is meant by the term vector quantity? Has both direction and magnitude. Draw labelled arrows on the diagram to show the other forces that act on the child. So remember, you're going to have weight acting downwards, and then acting in this direction against velocity, you're going to have drag or air resistance. State what is meant by the term electric current. It's the rate of flow of charge. Diagram 1 shows an electric circuit used to test a fuse. Give a reason why an LED is included in the circuit, because remember that emits light when the current flows. Add another component to the circuit in diagram 1 to measure the current in the fuse. Remember, you'll need an ammeter to do that, and an ammeter is always added in series, so it doesn't really matter where it goes in. Diagram 2 shows a different electric circuit containing 3 different lamps. Calculate the current I1. So that's here. So it's a parallel circuit, which means that the individual currents here will add up to the current at the power supply. So if that is 0.6 amps coming out of the power supply, then we know that 0.2 plus what we're after plus 0.3 will add up. So just solve for x to get 0.1 amps. State the current in I2, so coming back, that should be the same as what's coming out, so that's 0.6. Explain which lamp is the brightest. It's going to be the one receiving most current, so that's going to be lamp 3. And you can also prove it using this equation. Due to power equals current times voltage, and the fact that in a parallel circuit, remember, voltage is the same everywhere. The current in lamp 3 must be greatest. The photograph shows a toy car. When the toy car is pulled backwards, energy is stored in the elastic store as the rubber band is twisted. When the car is released, some of the energy from the elastic store is transferred to kinetic store of the car. The remaining energy is transferred into the thermal store of the surroundings. State what is meant by the principle of the conservation of energy. That is, that energy cannot be created or destroyed, it can only be transferred. The car is pulled backwards so that there is 165 joules of energy in its elastic store. When the car is released, the energy is transferred to the car's kinetic energy store at an efficiency of 15%. State the formula linking efficiency, useful energy output over total energy input. Calculate the energy transferred into the thermal store of the surroundings. This is effectively the wasted energy. So what we're going to have to do is work out the useful energy up here and then take it away from that total energy input. So we know that it's 15% efficient, so it's 0.15 equals x divided by that total energy, which is 165 joules. So solve for x by doing 0.15 times 165, and then that final step is to take away that number to find the wasted energy. So the answer is 140. Draw a labelled Sankey diagram for this energy transfer. So yeah, we've only got 24.75 useful energy. Tons of wasted energy, so make sure that arrow is wider. So let's label it. So this is useful energy output, which remember was 24.75 joules. This is wasted energy output, which is 140 joules, there and thereabouts. And then that total energy input was 165 joules. The car is pulled backwards again. When released, 45 joules of energy transfers to the car's kinetic store. The car travels a distance of 7.5 metres during this energy transfer. State the useful work done. Remember, work done is also measured in joules, so that's why it's just 45. Calculate the mean accelerating force acting on the car. So this is the formula triangle you want, which states that work done is force times distance. So we're doing force equals work done over distance. The work done was 45, the distance was 7.5. Pop that into your calculator to get a value of 6. Diagram 1 shows a plastic bottle containing water. State the formula linking pressure difference, height, density and gravitational field strength. It looks like this. It's height times rho, which is density, times gravitational force. The pressure difference between the surface of the water and the water at the bottom is 2,300 pascals. Calculate the depth of the water, give your answer in centimetres. So just substitute in your values. We're looking for the height. Our density is 1,000. Gravitational force is 10. Remember, you need to learn that value. Solve for h to get 0.23 metres, which is the equivalent of 23 centimetres. 3 holes are made in the bottle at positions A, B and C. Diagram 2 shows the path of the water leaving the bottle from hole B. Draw a line on the diagram 2 to show the path of the water leaving the bottle from hole A. So because it's up here, remember pressure increases the deeper down we go, hence why that water is being forced out so far. So you're just going to see that path take a kind of more inner route like this. Explain the path of the water leaving the bottle from hole A. So I've accidentally already done that. We're going to say pressure is lower at A because the force, that's really the weight of the water acting at A. The force acting on A is less. And that's 2 separate points for our 2 marks. Hole C is at the same depth in the bottle as hole B, but on the opposite side of the bottle. Explain the shape of the path of the water leaving the bottle from hole C. So we've been told it's the same depth, so we would pretty much expect to see an identical path simply because that pressure is the same. And then we've got our 2 marks, and then you just want to point out that thing it says in the specification. Remember, the specification is something you need to refer to all the time, which is that pressure acts equally in all directions. Suggest why there is a hole in the cap of the bottle. Well, really, because you've got that water leaving the bottle, the last thing you want to do is create a vacuum up here as the water levels decrease. So that hole in the cap allows air to enter the bottle. The photograph shows a vertical drop ride at an amusement park. The car is pulled to the top of the vertical shaft and released from rest. Okay, there's a key word, rest. So that means our starting speed is 0. The car then falls freely because of the force of gravity. Calculate the speed of the car. So that's the final speed v when the car has fallen 18 meters. So that 18 meters, remember, is distance. So that's s. This term down here is important. The car then falls freely because of the force of gravity. That means it's going to be accelerating at a rate of 10 meters per second. So this is a SwH question. Do be prepared to find these hidden amongst other questions. We're being asked to find v. I've already said that our initial speed is 0. We're doing 2 lots of acceleration, which is 10 times that distance, 18. Sort out the right-hand side. 2 times 10 times 18 is 360. And then square root to find the value of v, and that is 19. State the formula linking kinetic energy, mass and speed. Ke equals half mv squared. The mass of the car and its passengers is 2.1 tonnes. Calculate the kinetic energy of the car when it's fallen 18 metres. So write out your equation again. We're being asked to find the kinetic energy. Let's get our mass into kilograms. So we're going to do 2.1 times 1,000. Our speed squared. So we know that the speed we've just calculated is 19. So let's square that. Put that into your calculator. And to two significant figures, you get a value of 380,000 joules. The actual speed of the car when it has fallen 18 metres is lower than the value calculated in A. Describe the energy transfers occurring from immediately before the car was released to when the car has fallen 18 metres. Refer to stores and transfers in your answer. So at height, the car has gravitational store. When it's released, the energy is transferred to a kinetic store. And this transfer occurs mechanically. And energy is wasted by heating because remember, it says that the actual speed of the car when it has fallen is lower than the value calculated in A, so that would infer wasted energy. A steel ball is fired from a launcher on an adjustable table. A student investigates how the range of the steel ball varies with the height of the table. Describe a method for the student's investigation. Your answer should include details of the variables in the investigation, how the investigation will be a valid, fair test, how the range will be measured accurately. Let's start with our variables. So the independent variable is what you change. So we're looking at how the range of the steel ball varies with the height of the table. So we're changing the height of the table. Let's bulk out the detail here by giving some heights. So anything sensible, but I'm going to go for 10 centimetres, 20, 30, 40, 50 centimetres. What about our dependent variable? So remember, this is what we're measuring. So look back. A student investigates how the range of a steel ball varies. So we're looking at this distance here. Then let's go for our control variables. So what are we keeping the same? List at least 3. Well, what will affect that range of the ball? Well, the launch speed. So we need to make sure that's kept the same. We need to use the same ball. We need to keep the angle of launch the same. Anything that could affect the range. How are we going to ensure that it's valid? We want to repeat and calculate an average for each height used. And then in terms of this accuracy element, use a ruler with small increments to measure both height of table and the range. So our 6 marks are awarded as follows: mentioning the height of the table, giving at least 5 different heights, correctly identifying the range. There are 2 marks available for control variables, so we're already on 5 marks. Repeating, calculating an average is a mark, using that ruler as a mark. The graph shows the student's results. Draw a curve of best fit. So draw that freehand. Yep, that's absolutely fine. Estimate what the height of the table would be when the range of the projectile is 0.6 meters. So read up here on the y-axis. Take it down. Try and read that nice and accurately. So that would be around 0.35. justify why the student has plotted a line graph rather than bar chart. Remember, line graphs are for continuous data, whereas bar charts are for discontinuous or categoric data. The range of the projectile is related to the table height by this formula. Using data from the graph, show that the launch speed of the projectile is approximately 3 meters per second. So let's go in. Doesn't matter which point you pick. I'm going to go for this one just because it's easy for me to see. So I can see that the range is 1.5, the height is 1.2. So put all those numbers in the right place. We're being asked to find the launch speed. So I'm going to start by doing 1.2 divided by 5, square root my answer. Don't round that number too soon. And then divide 1.5 by that answer to get 3.06. And happy days, look, that is approximately 3. So I know that that's correct. Photograph 1 shows part of an ammeter that can measure very small currents. Look, it's measuring in milliamps. The student moves a wire between the poles of a strong magnet. So this is the generator effect, and uses the ammeter to measure the induced current. Determine the current reading shown by the ammeter. So read that very carefully. It's 2.8 milliamps. Predict a value for the current if the movement of the wire was repeated with the poles of the magnet reversed. So we'd expect it to move in this direction by about the same amount, so that would be minus 2.8. Predict a value for the current if the wires move faster. So I think we want to keep to the positive side, but it's going to create a greater current, so let's just go for 8. You could have picked anything basically higher than that number, original number. Photograph 2 shows the structure of the ammeter. The ammeter has a needle attached to a coil of wire which can move freely around a magnet. When there's current in the coil, the needle moves. The larger the current, the more the coil turns. Suggest how the design of the ammeter could be modified to increase its sensitivity. Anything sensible here, like using a longer needle, having more turns in the coil, having a stronger magnet. I'm going to go for use a longer needle. Photograph 3 shows part of the ammeter after a student has adjusted the ammeter in error. The needle on the ammeter does not point to 0 when there's no current. Which of these factors has been decreased by the student's adjustment? Definitely the accuracy. That is going to generate an incorrect value. Suggest how the student could correct the readings taken from this ammeter due to this error without adjusting the ammeter. You just want to look at that value and just add that number to whatever the reading is. And that signals the end of the paper.